Yeah, let me get into problem. So first you see this. So there's having a mass m, if telling a force of magnitude F naught exert for sufficient long time onto conductor so that the speed of wire becomes nearly constant. The force F naught is now removed at certain point P. What distance does the conductor cover on the rails from point P before stopping? You have to really no need of so like a it will move with a constant velocity. So initially, so you I think you have to go back to the basic things what you learned. There are so many things you learned, no? So if you can recollect some EMI problems, what we did, no? The initial in the beginning, what we did, motion EMF problem, though those ideas will help you to save time here. So initially, let's begin the problem. This rod is at rest. I'm going to apply force. So this is a test. This is everywhere B bar is out of the plane. It is understood. No. So I'll apply force. So what is the state of rod? It is at rest. So what will happen now? So as it starts moving, as you start pulling it, it will accelerate from rest. Then after some time, so it will at any instant of time, there will be some in place of rod, what we can be, or I'll show one thing. Okay, this is the F naught continues to be acting here, BI1L you call it. Then it will have a velocity, say V1. Still it will be accelerating. So as because of acceleration, velocity will increase. So therefore current I1 will increase and it will behave like a cell also. It will behave like a cell also. It will have potential difference. EMF will be generated. What is EMF is equal to? In this diagram only, let me write. So BL V1. Fine. And there will be induced current. I1 will be flowing. And what is I1? Equal to this one. After long term, finally what happened? Because of this, the velocity, because of acceleration, the velocity will keep on increase, and because of increasing velocity, EMF will induced EMF will increase, and as induced EMF increases, the current I1 will increase. Just like a story, if you can recollect it, straight away you can get into problem. I'm explaining everything, the basic idea. So therefore, as I1 increases, so what do you expect? BI1L will increase. At one instant, both these forces will become equal. That is what is starting the problem from there. This is t equal to 0. Next, we have t equal to infinity. So here, what will happen? The right I naught. So and it will move with a terminal velocity. Will there be any flow of current? Current is clockwise now. Got habituated for showing. I'll show it clockwise. I1, I1, I1. Will there be any current after long time?
Yes.
Yes, there should be a current. So this will call I naught. No, still. So now, okay, you get into the problem. So what we have to do, F naught equal to B I naught L. What is I naught? I naught should be equal to E naught by R. What is E naught? BL terminal velocity. I think this directly, you know this formula. You can start from here. So what is the terminal velocity? This one. F naught R by B square L square. So what is being done? This force F naught is removed now. Now removed at a certain point. What distance does the conducting wire cover on rail from? So now what is this next part of question? It is just like a projected, no? Some 2-3 basic ideas, he has just combined it. Let me keep it here only. So now if this is not there, so it is projected with a velocity Vt. So will there be any BL force? So I think at any instant of time t. So the force is removed, then only this rod will have say velocity v. So again there'll be induced current and a BL force. So now what will happen to rod? Rod will undergo retardation. Call this as I2. Will undergo retardation and finally it come to rest here. What distance does the conducting wire cover on the rail from point P before stopping? Because you see that there is no external forces there. F naught is removed. It will slide some distance, it will come to rest. I think the sequence one has to understand. If you can imagine, it's well and good. In exam, you can avoid the diagrams. Huh? He's asking that distance. Finally, it will come to say rest. We have to calculate this distance. Why did it will come to rest? This will undergo retardation. Okay, go for E equal to minus d phi by dt. Flux positive, positive flux increasing, d phi by dt positive, EMF induced positive, the d phi by dt positive, EMF induced negative. Negative means should be clockwise, no? Conventions, huh? So it's not some movie where you'll remember something. You have to conventions. I think the total EMI chapter revolves around this convention. Flux positive, positive flux increasing, d phi by dt positive, and minus of d phi by dt, EMF negative. Negative means should be clockwise. Every numerical, please put effort. 1 time, 2 time, 3 time, 4 time, 100 times, 1000 times. First get the direction of current first. Then you go for other things. Because if you go wrong with the direction, what is the biggest problem? What is the biggest problem we are going to face? We are going to face with a law of conservation of energy will get violated. I'll write that all the flux one in the corner here. Flux positive, d phi by dt positive, EMF induced negative. Negative means should be clockwise. What to do? How to get the distance x? Whose help we have to take it? What is the force? Variable force is acting, no? So shall we go for anything work done? Nothing directly. The retardation A2 should be equal to BIL2LR. So this will be B square L square V by R. It's a retardation, no?
MR.
MR. Next step will come. So therefore, this A2 should be equal to B square L square V by MR. dV by ds, negative sign.
ds, sir. We will get cancelled.
Okay, v dv by ds. So that will get cancelled. So b square L square mr ds. Velocity is v naught. We calculate terminal velocity vt. This is 0. This is x. Solve it.
32.
Let me write it as how much s will be?
32, sir.
32. 320 given. Check answer. Resistance R is 0.01. Length is 10 centimeter. Meter you have to convert. If it is a bulb, can you say anything about the intensity of the bulb? Brightness of the bulb? Brightness of the bulb. If this is a bulb, what happened to brightness of the bulb? First will increase. It will increase. Then, so finally when it is moving, terminal velocity will be constant. Then when you remove force, the brightness will decrease. Am I right? If this were a bulb, the brightness of the bulb will gradually, will increase. Once it attains terminal velocity, brightness will be constant. Then once you remove force, it starts decreasing. So instead of resistor R, I'll connect a bulb of resistance R. Then I'll